Hey everyone, welcome back. Today we are going to learn about Agentic AI and a powerful tool called Llama. So I'll explain you what they are and what are the models available. And then we'll also build a small project using the V3 Mini, which is a lightweight AI model. And by the end, you'll be able to run AI fully on your own computer. So first, let me explain what Agentic AI is. So normally AI just responds to prompts, but agentic AI goes further. It can reason, plan, and take actions on its own, like using tools, browsing data, or helping with workflows. Think of it like an AI assistant that's not just answering, but actually doing things for you. Huh? So now let's talk about what Ollama is. So, Ollama is a free open source tool that lets you run large language models locally on your computer. That means you don't need the internet or cloud services. This you get privacy, your data stays on your machine. There's flexibility, you can switch between models, and the speed is optimized for your GPU or CPU. So, Ollama offers a bunch of models. Uh, some of the popular ones are Gemma, Mistral, and V3 Mini. Gemma is a Google's open model, and Mistral is great for reasoning tasks, and V3 Mini is Microsoft's small but powerful model, perfect for quick projects. And today we'll be using the V3 Mini since it's fast and runs even on modest laptops. So let's quickly install Ollama. So we'll go to ollama.com, click on download, pick your OS, here we'll be choosing the Windows, and download for Windows. Click on install. So once this downloads, then we'll run our first model on the terminal. As you can see, the Ollama has downloaded. Open terminal. Now we'll run the Ollama model. Now we'll run it. So V3 Mini is a compact, high-performance language model with approximately 3.8 billion parameters, and it belongs to the V3 family by Microsoft, which also includes V3 Medium, which is around 14B parameters. It's trained on trillions of tokens from filtered high quality public web data and synthetic data using both the supervised fine tuning and preference optimization for instruction following ability. Now we'll try giving a prompt. So let's say explain Python in one line. So here it has, here we can see the response. Python is an interpreted high-level general purpose programming language with dynamic semantics. Let's start with building our project using Ollama and LangChain. So instead of diving deep into our code for the project, we'll try some basic things first, and then we'll slowly build our way to the project. So we always wish AI could, not just give answers but also act like a little assistant, planning and reviewing and producing structured results. So that's what we are going to build today. So the project is called Agentic AI pipeline with Ollama and LangChain, and we'll build it piece by piece. So at its core, a project takes a blog post title and content and runs it through two AI agents. That is the planner agent and the reviewer agent. The planner agent, it reads the blog, it will generate three tags and one sentence summary. And the reviewer agent, it double checks the planner's work and improves it if needed. Finally, we'll also ensure some rules like it should always give three tags and not more than three tags, and the summary should be like less than 25 words. The program then prints four clear sections: the planner's output, the reviewer's output, and the finalized output, and the publish package JSON. And at the end, it also prints a submission date in UTC format. So this is important because this is a real example of agentic AI. Instead of just uh, uh, spitting out free text, we are creating a system of agents that reason about content, review and refines it, and enforces a structure, and finally delivers a clean, reliable JSON. So that's exactly what you would want if you were building a real app, say summarizing blog posts, tagging news articles, or autofilling a database. So before we code, let's talk about what you'll need. So Ollama, first thing is Ollama. This runs AI models locally on your computer. We'll be using the V3 mini model, like I said, and we've already pulled our model and run it. So, before starting with the code of our project, we'll try running small codes to understand how the models work. Right, and I'll also tell you what are the expectations from our project and what are the requirements, like what is the expected output we need and what are the requirements for it. So I'll tell you a bit about that first. So you would want AI not just to give you answers, but like you would want it to work like a assistant. So planning, reviewing, and producing structured results is what we want. So that's what we are going to build today. The project is called an Agentic AI pipeline with Ollama and LangChain, and we'll build it piece by piece. So at its core, our project takes a blog post title and content and runs it through two agents. The two agents are the planner agent and the reviewer agent. The planner agent reads the blogs, generates three tags, and one sentence summary. The reviewer agent, it double checks the planner's work and improves it if needed. Finally, we will enforce rules. Uh, that is, we need to get always need to get three tags and a summary of at most 25 words. The program then prints four clean sections: the planner output, the reviewer's output, the finalized, and the publisher package JSON. At the very end, it also prints a submission date. So, this is what a project is. So, you may ask why go through all this, because this is a real example of agentic AI. Instead of just spitting out free text, we are creating a system of agents that reason about content, that reviews and refines it, and it enforces a structure, and finally delivers a clean, reliable JSON. So that so that's exactly what you'd want if you were building a real app. Say like summarizing blog posts, tagging news articles, or autofilling a database. So before we code, let's talk about what you'll need. So we need Ollama. We have Ollama. We have already built it. The Ollama v3 mini model, and Python will need 3.11 or 3.12 because our code is written for modern Python. And we'll need two Python packages, that is LangChain Ollama and LangChain core. LangChain Ollama, it connects LangChain with Ollama, and LangChain core gives us message types like system message and human message. So once this is ready, you can run the project completely offline. Try running a simple code with one prompt and one reply. First, we'll import chat Ollama. This is the client that talks to your local Ollama server. Human message is human messages is LangChain standard user message container. Now we'll create the client that knows how to reach your Ollama server. Now here we'll put the model name which we pulled earlier. This is the default local server URL. Let's put our prompt over here. So basically dot invoke is to send a request. It expects a list of messages even if it's only one. And here we put the actual prompt we sent. Let's say hi in 5 words, and we'll print a response. The model's text will get printed here. So here we can see after running our code, hi, nice to meet you. How can I help you? This is almost 5 words. So this is the response which we have got. Now we'll make the model return JSON only. So the goal is for our pipeline, we need a structured output, not free text. So let's try to return a JSON. So here we'll put our format. So here in system, we'll tell our model in exactly what shape to return. So we'll tell return only one JSON object with keys, thought, and message. Now we'll give a specific user task. Let's give a topic. Our topic will be, let's say, quantum computing. So we send both messages, the rules first and then the task. So there's an error. Let's fix this error. So here it says system message is not defined. So let's import system messages as well. And also, if you're only sending a user prompt, that knows you could skip system message and just do here we can just in content you can just put your prompt. their year-end content. But in our project, we need a file system message. We need system message to enforce schema like return JSON only. So here you can see our output has been returned with the JSON structure. So first we'll import some modules that we'll require, and I'll tell you uh, why and how we'll be using each of those modules. So argparse here is this helps us take command line arguments like title and content when we run the script. JSON is the built-in Python library to read and write JSON, which is the format we'll make our AI output. RE is for regular expressions, which we'll use later to split words. Time will help us measure how long each agent call takes in milliseconds. Warnings lets us hide warning messages so our console output looks clean. Here from datetime we import datetime and time zone to print the submission date. DC. From LangChain Ollama we import chat Ollama, which is our Python client for talk to. And finally from LangChain underscore core dot messages we import system message and human message. These letters send instructions and content separately to the model. This line just tells Python to ignore depreciate depreciation warning. That way, we only see the clear JSON sections in our output. Well, the third part of the code is to, which is our first helper function, that is extract JSON. Sometimes the model might give us extra text around the JSON or wrap it in a code fences. So what we do here is we find the first the open curly braces and the last curly braces and grab everything between them and try to parse it with Python's JSON.loads. If it works, we return the JSON as a Python dictionary. If it fails, we return none. This makes our pipeline more robust because AI models are not always perfectly obedient. So let's run the script to see if it prints a Python dictionary. As you can see, it does. The next part of our code is to enforce the schema helper. This function enforces rules on AI's out. Now we'll start with the definition to enforce schema helper. So this function enforces rules on the AI's output. So like I said, this function enforces rules on its output. Here first we try to get the tags list. We normalize them to lowercase, then remove spaces and keep at most 3 of them. And if we got fewer than 3 tags, we pad them with words from the block title. Then from the summary, we will limit it to 25 words and make sure it ends with punctuation. If the summary is empty, we make a default summary like a brief overview of title. This guarantees our JSON is always predictable and neat, no matter how messy the model's output was. So just we'll run a test here. We'll print and we'll write a print statement over here and run it. And let's see if it shows how if it returns 3 tags plus a clean summary. So here we can see it shows us the tags, and there is also one sentence of summary over here. We'll remove this print statement, and then now we'll print block helper. So this helper will print the block exactly in the style of our sample output. It shows a thought, message, and data. Notice that we don't print issues separately here, we'll keep them inside data. After this, we'll run agent helper. So the run agent does all the heavy lifting for both planner and review. So it takes the LLM client, a system prompt, and a user prompt. So let's start with the run agent helper function. We'll define it as run agent. So, like I said, it takes the LLM client, system prompt, and a user prompt, and we measure the start time, run the model with our messages, and measure how many milliseconds it took. Then we parse the raw JSON with extract underscore JSON. Then we build a block with thought, message, data, and keep issues inside data. Finally, we return the block and the time it took. This way, we can call any agent in just one line without rewriting this logic every time. Now let's put everything together inside a main function. The title is required because that's the block title, and the content is required because that's the block body text. Here we'll put our default model as the V3 mini. So the model lets us choose which Ollama model to run. We're defaulting it to the V3 mini, and over here the base URL is where our Ollama server runs. Usually it's the localhost. So here we'll put our local. Finally, we parse all this into args, which we'll use below. RJS is args, which is arguments, which we'll use below. And now we'll connect to Ollama. To keep the format as JSON. So this line connects us to our local Ollama model. We pass the model name and base URL from the arguments and set format is equal to JSON. So we always get structured JSON instead of free text. So this is our output. The first block is the planner. The planner's thought is like it's a reasoning node. It's saying the task is to summarize into one sentence within the word limit. The message is what the planner produced. Then you have three tags and a summary. Then in the reviewer block, there's a reviewer's thought. It's similar to the planners, but the message is slightly refined summary. And then you have the tags and no issues. And here we have the finalized output. The thought is always the same, meaning we have merged and enforced structure. The message repeats the planner's tag and summary. But notice the data section. The enforce function replaced the tags with three words from the title: impact of climate. The summary was replaced with the very generic fallback: brief overview of impact of climate change on agriculture. There's an enforcement at work, ensuring we always have three tags and a safe summary even if it's too strict. Then we have the publish package. The final JSON object we would actually save or send to an API. It includes the original title and content. The insight field comes from planner's message, its tag and summary. The reviewers list contains the reviewer's improved summary. Then we have tags and summary again, but these are from the enforced finalized output. And then the issue list is empty because there are no issues. And then we have the submission date. The very last line, it's printed in UTC time in ISO format that makes each run traceable to when it was generated. So that is it. We built a pipeline with two agents, a planner and a reviewer, and then enforced a clean schema and finally packaged everything into structured JSON with a timestamp. Along the way, we learned how to structure prompts with system and user messages, how to safely extract and enforce JSON outputs, and how to design a multi-step agentic AI flow that's reliable. This is a simple but powerful pattern you can use for many projects like blog summarization, report generation, or even automated content tagging. Yeah, so thanks for watching you all. If you found this helpful, don't forget to like and subscribe, and let me know in the comments what kind of agentic AI projects you'd like to see next.